Alright, you are welcome back again. So we just want to look at how to transform data in past. Data transformation. The same way the data is transformed in every other applications, the same way you can also do the same in past environments. And we are going to demonstrate by using our usual former data set which we have used before. So I just copy here, I go to past, I paste it as usual, just click here and paste here. Alright, so past supports several means of transformation. Okay, so don't forget last time we transformed, we saw that this particular column has some outliers. This particular column sepal width has some outliers. If you check your box plot now, let's say we check our box plot. Let me just say we do this together. All right, go to box plot. Okay, we check outlier. Can see outlier here. There are 3 outliers here showing here. Can you see that? Okay, so 3 outliers here. So we are trying to see how you can remove the outlier. How we can remove it. Okay, so let's see how we do this. Okay, so we can actually go to transform here. There are several methods of transformation here. Okay, we have log 10, we have subtract mean, we have move trend. So you have to try each of them to see which one work for your data, right? Because data are not the same. Data are different, and this particular transformation also they are different. So for example, if I use a row normal length, for example, now this is a what they call cost transformation family. So if I run this, for example, to change, don't forget that I didn't do this alone. Sepal width, even though is the one that having problem, I mean, it has some outliers, because if you do only one, the shape of data will not be uniform anymore. All right, the shape of data will not be uniform. So you have to do for everything together. So you don't just do for one. But do for one, if you look like this, other one will now look different. So which means they have different measurements, different scale. Okay, so that will be a problem. So it won't be able to analyze properly. Okay, so in that case, you have to do for all of them. So now I come here back again to see. Let me see if there's any effect of that in my data. So now if I check my outlier again, no more outlier here, that has gone. You can see it has gone. But I want to let you know that that does not really mean the data perfect. Okay, you need to do a further analysis, further test to confirm that the data is okay. So by removing outliers that are not extreme does not necessarily make data perfect or normal. Okay, so you need to do a further test to confirm the data is okay for you to carry out parametric test. All right, so not only this, we can also perform a normal expression. For example, expression here, which means maybe you have something like, for example, now if you check here, look at it now, we have a common transformation method. We have a standardization, for example, which means we have z equals to x minus mean all over standard deviation. Okay, so this is how past. This is how you do it in past. How past does it? Okay, s minus mean over stdv. So this is how past does it. Or you want to do a normalization, s minus minimum of s all over maximum of s minus minimum of s. You do this how past does it. S minus mean over maximum minus mean. That is how s does it. So you can have also log to base 10 s and expressional s. So this is how past does it. This past way. Okay, so you can also do this in past. If you have your own formula, let's say we undo this now. We just undo. Okay, to go back to the our normal data. Okay, so you can just go to transform, for example, and go to evaluate expression. Okay, here. Okay, you click here, we type, let's say I want to use this normalization, for example. I type here mean, okay, mean of s, okay, s minus minimum divided by maximum minus minimum. So this is my formula. Okay, that's the formula I just showed now. This is how you put it here. this way past the CFIT. Okay, so if you compute this now, there's no error. Okay, it has computed. It's computed, so you can close this. All right, so now I can check. Maybe I can check again. Let me see if there's any effect of this on my data. All right. Okay, so if I check now, so there's still outlier. Okay, in my data, yes, it does not really affect outlier there, though it may improve the normalization process. Or if I check my, let me say I check again my normality test again. Let me see the effect if it actually affected it. Okay. Okay, so we see that it does not only this one still remain significant. I mean, remain pass the test 0.1. This one still fail the test. This one fail the test, and this one also fail the test. So it does not really affect it much. Okay, it doesn't have any effect on it. So you can do this. Okay, you can also do the same thing. Maybe the one I did last time. Can just say okay, s minus let's say all over STDV standard deviation. Okay, this one is mean now. S minus mean. Just test that mean here. Okay, so S minus mean. This one is a standardization. Like for example, okay, you can compute here. All right. So this is how you do it. Just take notes. All right. So close. Let me see if there's any changes, any effect here. Okay, so see have my outlier, see have my outlier here. Does not affect my outlier. So it does affect a test. Let's say so it doesn't affect the test. Okay, since I say this one remains significant. So all right, so you can just undo. All right, can log. All right, can log. Okay, so that is how you perform. There are many ones you can perform. In case you have your own formula you want to supply, just use the same method and supply your formula. There are many expressions there that you can use in that particular environment. Okay, in that regular, allow you to use your own formula. You can see all those absolutes, tan, sine, square root, tan, and the rest of them. You can see all the formulas. You can just apply them and use it to normalize your data. All right. So this is just how to normalize in past. Okay. But I will advise that if you want to do that, number one, don't just normalize only one column. Okay, because it will make the data non-uniform. Okay, it will give data different scales, different measurements. All right. Now, number two is that when you are normalizing in an environment in the past like this, for example, you don't normalize beyond log, exponential, and square root if you are using the data for statistical analysis, statistical test. For example, parametric test, don't go beyond log, square root, and exponential. Don't try to use the normalized method I use here. Okay, like this one or this one for when you are performing statistical analysis, because it will completely change the shape of the data. Absolutely. Okay, your data shape will be completely changed. Okay, and to affect the results. If you are performing probably machine learning, very good. You can apply any kind of formula you want. You can do the scaling, which is a maximum and minimum. You can do normalization. You can do anything. You can perform bring in any formula you want. But if you are doing statistical analysis, statistical test, don't go beyond that three aforementioned, because it will affect your data seriously. So if you are done normalizing, for example, if I normalize, for example, here, maybe I use box plot. It gives me this. I just transform. So this is my new data. So I want to copy now. If I copy this now, I cannot copy like this because it will only copy the data. Don't copy the column headings, which is not bad. But for example, I've copied now. I've copied already now. I click on copy. So I want to paste here. Just say Control V paste. So everything is here, very fine. But I don't have the column headings. So you may need the column heading. If you have a lot of, maybe you have like 10 or 20 columns, for example, you may not want to be typing them one by one. So you just need to go back again. This method you use, just check your columns here. Can you see? Right, and I select all. Right, or you can just remove select all. Okay, let me just click from here. I hold down my shift key, click here, click here, click here, and click here. Okay, so why I left this one checked. Okay, I left this one checked. So now I copy. I click on copy now. I come here to my Excel. So I just paste here. Right. So what I need to do is just remove this line. Okay, I delete this. So I have my data now back here with a new transform one that I have transformed. Okay, and so this is my new data that I transformed. So it makes the work easy. Okay, you don't need to be doing the work manually one by one. So you can just bring it back here to Excel. So after when you are done, so this is how to transform data in parse. You can go further and do more as much as you can. So this is just an introduction. Thank you so much for listening. I will see you at the next class.